Hi everyone, my name is Miriam and this is my final project for the Managing Machine Learning course. Today I will be walking you through my solution titled Machine Learning Powered Churn Prediction in Medicare Advantage. The problem I'm tackling is predicting which Medicare Advantage members are at high risk of disenrolling within the next 6 months. This matters because when members leave, it impacts revenue, continuity of care, and quality metrics like star ratings. By using machine learning, we can flag at-risk members early and intervene before they disenroll. So why is this a good opportunity for machine learning? First, there's rich data available, such as claims history, call logs, demographics, and risk scores. Second, churn tends to follow identifiable patterns, like reduced utilization or increased complaints. Third, there's clear value in acting on predictions. Preventing just 1% of churn in a 100,000 member plan can save millions annually and improve overall plan performance. In CRISP-DM, short for Cross-Industry Standard Process for Data Mining, the first phase is business understanding. The business problem is identifying members likely to disenroll in the next 6 months. Success means improving retention rates and helping the plan take timely action. We will measure success through 2 key metrics: an outcome metric, the actual retention improvement, and output metric, the model's predictive performance, such as AUC, area under the curve. And the business impact is significant. Retaining even 1% of members translates into major financial gains and continuity in care. Some key features the model will use include changes in claims frequency or service use, risk scores and demographic details, call center complaint logs, network usage trends, and potentially CAHPS data, which stands for Consumer Assessment of Healthcare Providers and Systems, if available. These features give a 360-degree view of member behavior and experience. Here's how I would validate this solution. I would start with a classification model like XGBoost or logistic regression. I would backtest using past churn data to check predictive accuracy. Also, I would involve retention teams to review if the model flags members they already suspect are at risk. And finally, A/B test interventions, comparing retention outcomes between flagged members who receive outreach versus those who don't. Next are the 3 system design choices. First, batch versus real time. Churn isn't immediate, so we can use batch processing, such as weekly or monthly runs. 2, human in the loop. So yes, we want to flag at-risk members for care navigators or outreach teams who will determine the right next step. And 3, monitoring and updating. The model will be retrained quarterly with active monitoring of AUC and feature importance to detect drift over time. A few risks to consider are training serving skew, if code definitions change in production but not in the training dataset, data drift, such as shifts in member behavior from benefit design changes, concept drift, for example, if member expectations change post-pandemic, and lastly, HIPAA compliance, short for Health Insurance Portability and Accountability Act, must be strictly followed when using PHI, protected health information. Being proactive about these risks will help maintain trust and performance once the model is live. To wrap up, machine learning offers a powerful way to predict and reduce churn in Medicare Advantage, leading to better business outcomes and member care. By identifying and supporting at-risk members early, we not only save costs, but also ensure they continue receiving the care they need. Thank you for viewing this presentation on machine learning powered churn prediction in Medicare Advantage.